Welcome to Ask and Learn.
This is the answer to Chapter 20, problem number 55 from the Smith Organic Chemistry textbook. This problem asks us to draw a stepwise mechanism for each of these two reactions. So in A, we have this lactone that we're treating with methyl magnesium bromide. And we end up with a non-cyclic product. And if you count carbons, you can see that we've added two methyl groups. And so we need to draw a mechanism that's going to account for that. Okay, and so the first thing that's going to happen here is methyl magnesium bromide is going to attack the carbonyl carbon in the typical fashion of a Grignard reagent. So like this. And so after that first step, we have this intermediate. So we've added our methyl group here. We have the alkoxide here. I forgot to draw the oxygen right here, so let me fix that. Okay, so we have this alkoxide with a negative charge. We've added our methyl group. And so the next thing that can happen is the alkoxide can go to reform the double bond there. That's going to cause this bond to break, this other carbon-oxygen bond. And when that happens, that is going to open up our ring. And so now, 3, 4, 5, 6. So now we'll have this with a ketone here. And the alkoxide over here. Okay. And so from here, and let me just double check. Right, yeah, so the problem specifies that we're using excess methyl magnesium bromide. And the reason it has to be excess is because we can now have a second equivalent of methyl magnesium bromide come in and attack this ketone. And so again, this will proceed just like a regular Grignard. And so we now have another methyl group here and an alkoxide here. And so we have two alkoxides now. And when we go to do our water workup, we can take care of both of these at the same time. So we can draw both of these being protonated at the same time as a single step. I shouldn't omit negative charges, so each of these has a negative charge. And we can just draw each of them grabbing a proton from different water molecules simultaneously. And so that is going to get us to our final product, which would be this diol. Okay, so that's part A. So then for part B, we have this other lactone that we're starting with. And this time we're using a di-Grignard reagent. So it's a butane chain with a magnesium bromide on either end of it. Okay, and so the starting step again is going to be just a typical Grignard. So 1, 2, 3, 4. So we have this di-Grignard reagent. That's going to come and attack the carbonyl. So we should by now be familiar with the electron movements here. And so after that first step, we will be here. So we have our alkoxide. We have 1, 2, 3, 4 carbons, and the other Grignard, or the Grignard that's on the other end of that chain, still intact. Again, that's an alkoxide there. And so very similarly to part A of this problem, the alkoxide can reform that double bond, and the bond between the carbon and the other oxygen can break. And so when that happens, we end up with something that looks like this. So we'll put the magnesium bromide on this side. So our ketone will be here. And our alkoxide will be right here. Okay. And now the Grignard that we still have can attack our ketone. So just like this. When that happens, we're going to form a new 5-membered ring. So there's our new 5-membered ring. Here's going to be our alkoxide. And then here's the rest of the molecule with the other alkoxide. So let me put my lone pairs in. So there's one alkoxide. There's the second alkoxide. And then once again, we can draw both of these being protonated in a single step by 2 different molecules of water. And so each of these can just grab a proton from a water. And that is going to get us to our final product here. Okay, so there we go. And in both of these, the common theme was the Grignard reagent is going to attack the carbonyl carbon. That alkoxide that forms is actually going to close back down and reform that double bond, which is going to break the bond between the carbon and the other oxygen in the lactone and open the lactone up. And then from there, we're going to get attack on the new ketone, either by another equivalent of Grignard, as in part A, or by the Grignard that was on the other end of our starting Grignard in part B. And then just protonation of the resulting alkoxides gets us to the final products. And that's the answer to chapter 20, problem number 55.